Hello students, welcome to my channel. In this video, I will revise you the important concepts in center of mass and collision chapter. These are required to solve the problems in IIT-JEE mains examination. It is a quick revision of this chapter. Okay, fine. So, in the center of mass, two types of questions will be framed. One is direct formula based questions or indirect questions. In direct formula based questions, you need to apply the formula to solve that question. For example, what is the basic definition of center of mass? The position of center of mass. So how will define the position of center of mass? The standard way of defining position of center of mass will be m1 r1 plus m2 r2 and so on divided by m1 plus m2. Here r indicates x coordinate plus y coordinate plus z coordinate, all three quantities. Okay. So after this, simply velocity is the same way, m1 v1 plus m2 v2 and so on divided by m1 plus m2 plus and so on. Similarly, acceleration of center of mass, m1 a1 plus m2 a2 and so on divided by m1 plus m2 plus and so on. So what about the linear momentum of center of mass? So linear momentum of center of mass simply vector sum of individual momentum of the particles. Okay. So this is the way of simple definitions of position, velocity, acceleration and linear momentum. Okay. So you need to remember the standard formula for standard objects. For example, if there is a rod, where the center of mass of rod is located, so at a distance of L by 2 from any one end. Suppose if there is a triangle of height h, then where will be the center of mass of the triangle is located? The center of mass of the triangle is located h by 3 from the base, and h will be the height. So similarly, for example, semicircular ring. So half of the ring I have taken. So where is the center of mass of this half of the ring will be located? For the semicircular ring, the center of mass will be located at a distance of 2r by pi. So something like I have a semicircular ring. I need to determine the position of center of mass, which is somewhere here. It is 2r by pi. Similarly, so half of the disk will be there. So for this also there is a direct formula, 4r by 3 pi. So if you take any standard book, it may be your lecture notes, whatever it may be. So NCERT book or H.C. Verma book, any book you take, just simple formulas you need to by heart this. So similarly, for example, if I take a hemisphere, hollow sphere, the center of mass will be located at r by 2. So for example, if I take solid one, the same thing. If I take it is hollow. If I take the solid, so it will be from 3r by 8 from the base. Okay. Suppose cone, if I take cone, hollow cone, it will be h by 3. Solid cone, it will be h by 4 from the base. Okay. So these are the formulas you need to remember, direct formula based. So what will be the indirect type of questions will be framed here? In case of, if you see here, indirect questions in the sense, for example, so there will be a complete part. From the complete part, so they will remove some part and ask they'll remove or delete, whatever you can say. They will remove some part or delete some part and ask for where will be the center of mass is located for the remainings. For example, from a big disk, a small disk is removed. From a big triangle, a small circle is removed, anything, whatever it may be. So the idea for this complete part will be is equal to deleted part plus remaining part. Okay. So another type of questions, indirect questions, will be something like if you want to determine the position of center of mass for the case where the mass of the given object is not uniform, it will be varying. So in case of the mass of the object is varying, the standard definition will be for center of mass, it is, we write something like this. If it is x coordinate, then I'll write x. If it is y coordinate, I'll write for y. So the important thing will be dm. How you will take the mass element? So the mass element can be linear. If it is a like wire rod, something like this, lambda multiplied by dx. If it is a square plate, any 2D objects which has some given area, that time I need to write sigma into area element. If it is a 3-dimensional element, density multiplied by volume element. Okay. So depending upon the which problem you are solving, suppose if you are taking the area element, then we need mass per unit area, that is surface mass density, sigma. Suppose you are dealing with the 3D objects, volume element will be there. You require the mass per unit volume, mass density. Okay. So if there is a question like that, then we can approach in this manner. Similarly, another indirect of questions are otherwise the ideas we need to remember. So will be something like conservation of linear momentum, first idea. So linear momentum initially will be is equal to linear momentum of the system finally. So this idea is also helpful for us. Linear momentum of the system finally will be is equal to linear momentum of the system initially. So something like if you take the standard problem, there is a gun and bullet problem will be there. So when the bullet comes out from the gun with a velocity u, so let's say u1, then what will be the recoil velocity of this? So let's say v2 I am writing. What is the recoil velocity of these things will be? So if I can take this will be something like m1 or m2. This is m1 and its velocity will be v1. Simply I can apply here conservation of linear momentum. So before the linear momentum of the system is 0, then after must be 0. That's why one is going in the forward direction, another one will be going in the backward direction. I can apply here m1 v1 will be is equal to m2 v2. So remember here v1 and v2 are the absolute velocities. They are not relative velocities. Okay. Similarly, sometimes there may be situation something like a big object will be here. So during like maybe some explosion, whatever it may be. So it is break into two parts. One part is moving with a velocity, so v1 in the forward direction. So other part will go backside with a velocity v2. Then how will relate that velocities? Again the same formula. m1 v1 will be is equal to m2 v2. So this is the idea required. Okay. So especially if I consider the collision chapter, especially if I consider the collision topic, in the collision this idea is compulsory. Initial momentum of the system will be is equal to final momentum of the system, whether it is 1D collision or 2D collision, whatever it may be. Then after that I require the definition of coefficient of restitution. Coefficient of restitution I can define as velocity of separation by velocity of approach. Don't forget this should be along the line of impact, the direction along which normal force will be acting. Generally students will remember this will be something like this, v2 minus v1 by u1 minus u2. So something like here there is a mass m1 approaching an object of mass m2, which is already moving with the velocity u2. So approach will be here u1 minus u2. So the approach will be is here u1 minus u2. Then after the collision, let's say m1 is moving with the velocity v1 and m2 is moving with the velocity v2. Then what is the separation will be here, that is v2 minus v1. So related to collision problem, this is the first idea is very important, and this will be the second idea E. So E will be 1 for perfectly elastic collisions. E is equal to 0 for perfectly inelastic collisions. E can be any value in between 0 to 1 if simply inelastic collisions. It is inelastic. This is perfectly elastic. This is perfectly inelastic. Okay. So even you can decide the problem based on like loss of energy. In case of perfectly elastic collisions where E equal to 1, kinetic energy before the collision is same as that of after the collision. Kinetic energy after the collision will be is equal to kinetic energy before the collision. But in case of perfectly inelastic collision where E is equal to 0, there is a maximum loss of energy will be there. This is the maximum loss of energy that can be determined kinetic energy before collision minus kinetic energy after collision. Okay, so these are the few ideas which are required to solve the problems. So let us take the problems directly from the previous NEET questions, previous JEE mains or even NEET from 2024 or 2023, 2022. In the next videos, I will explain you, I will demonstrate you directly some of the questions which are asked in the previous IIT-JEE mains questions and even NEET questions also. Okay. So thank you for watching my video. Please subscribe and share to your friends. Thank you very much.